Okay, so we're going to talk a little bit about the second micro lab, and this one is on using the define projection tool. So I want to go over the two tools that we use to change projections, because one changes projections, one changes the label on the projection. And so you use them very different ways. If you have data that is projected properly, but you want it in a different projection, or you have data in a GCS and you want to project it, you use the project tool, and that tool will take your data set, read it, create a brand new data set in the new projection. The define projection tool is used when the projection is simply not defined or it's defined incorrectly. And so these slides are going to kind of go over some of that. And we're going to start by you're going to download some data that you're going to need. Here's a picture of my desktop screen at home, and I have the define project folder and the West Virginia counties folder. There's zip files. These are the files that you need to download and extract the data into a folder on your desktop. So make you a new folder on your desktop, download these, they're available on Canvas, and then extract them into your folder, and it should look something like this. There's the two files. The one in the middle, don't pay any attention to it, but you'll need to download your defined project and your West Virginia counties zip files. Again, they are in the Microlabs Canvas module. So once you do that, you get the little GUI pops up for your where to put it. And in this case, I made another folder called Data Projection. Added data projection is where I extracted all the data in these two folders. Next step you're going to open up is a simple blank map document, and we're going to do some stuff here to get ready for this lab. First thing you're going to do is make sure if your catalog pane isn't visible, you click on it there to make it visible over here on the right. Then you're going to go to your folder connections tab, again this little folder with the black plus symbol, and that will allow you to connect to the folder on your desktop, and that's important because you need to make sure that you have the right data that you're accessing. And so once that's done, the folder is then attached down here, and you see where it says client, users, desktop, and then everything's there. Now because I extracted that data, the data that I'm looking for is the data that I extracted into that folder. Once I've found that, connected to it, I'll have it all right here, and I can move that data into my table of contents, and I can start doing my lab. Okay, so once we're ready to start and you've got your map and you've got everything set up, you made your folder connections, now it's time to add in data, and the first data that you're going to add in is the county boundaries data set. And you see that this is the counties in West Virginia. And if you were to pop open the layer properties and look, you would see that this is in NAD 83 UTM Zone 17 North. It's a projected coordinate system, and if you look at the extent, you'll see that it's in meters, and it tells you a lot about the data. The next thing we're going to look at is what happens when we add in the historic places, and I've given you a hint here. It says GCS because it's in a GCS. When we go to add that data in, it doesn't do what we expect it will do, and you see that it's added in this slide, but it's not showing up. And the reason was when we added the data in, you get this warning. The following data sources are added, have missing spatial reference. It can be drawn, but it can't be projected. So they can create those points, but they can't place them relative to other things. So it's impossible. So that creates a problem. First thing we have to do is figure out why. So if we look at the layer properties for that GCS history places layer, I want to point out a couple of things. The first one is look up here at the extent and see these numbers. These are not meters. 40 to 30, negative 70, negative 80, that sounds an awful lot like geographic coordinates, which I've already told you it is in fact a GCS. And then below that, how the coordinate system is undefined. If the coordinate system is undefined, we use the define projection tool to fix it. If it's defined incorrectly, we use the define projection tool to fix it. If it's defined properly, but we want to change it, then we use the project tool. So we're going to be using the define projection tool because we want to change it from undefined to whatever we think it is. And this is another slide that's going to look probably a little weird from time to time. Let's start off with a background here of our map document, and we've opened up our toolbox, and so we can go in and find our define projection tool, which is in the toolbox under data management, under projections and transformations is where you find it, or you can just search for it. The next thing, gonna make that a little bit bigger just so you can see it. Again, toolbox, data management tools, projections and transformations, and then down at the bottom is the define projection tool. Right below it is the project tool. Don't use the project tool, use the define projection tool. Again, data management, and then projections and transformations, define projection tool. So here's how this kind of works. The define projection tool is really straightforward. It's only got two boxes. One is the data set you want to change, and the second one is what projected coordinate, or what coordinate system you want to put it in. So we already know this is in a GCS, and so our easiest and safest best guess is always to guess the GCS of the other data set. So we picked GCS North American 1983. And when you do that, you would click this little sort of dialog box there at the end of the text box where it says now GCS North America 1983, and that would pop up in the spatial properties element on the right, where you would then go through and find what you're looking for. In this case, under the GCSs, under US and territories, you can find NAT83 if that's in fact what you think it is. And once you do that, lo and behold, the darndest thing happens. The data points show up on top of the counties like they were correct. But if we zoom in out to the panhandle, you'll notice that some of these look like they might be actually out of the county. And turns out they are. So the first instinct is maybe we didn't pick the right GCS. Well, here's a big sort of thing you need to realize. That wasn't the right GCS. It's not NAT83. It was something else. But NAT83, NAD27, WGS84, all the most common ones in the US in terms of the location of the geographic coordinates themselves, are generally like plus or minus somewhere between 200 and 20 meters north, south, east, west. And so the points are really likely going to be almost exactly where they need to be. And the reason these points here showing up outside of the county boundary is because the historic places is at one scale and the county boundaries were drawn at another scale. It's the same scale. That historic place that's in West Virginia would be in West Virginia. Alright, so now you sort of see how that process works. Let's see what we're going to do next. I just zoomed in a little further to show you again that it's actually out. So now it's your turn to do this. And so I want you to add the project data set 2 and see if you can fix it. Now that data set is also posted on Canvas, and it's called Wrong Counties. And so what it is, I took the county data set and I projected it as something else, and then I cleared all the property box information so that the software won't know how to read it. And when you try to load it up, it's not going to load up, and you'll have an opportunity then to try your hand at doing this. Now here's the big hint. It's in a projected coordinate system. It's either NAT83 UTM Zone 17 North or projected coordinate system WGS84 Web Mercator Auxiliary Sphere. Try the NAT83 first and see what happens. If you use the define projection tool on that data set and you define it and they line up, then you know it worked. If they do not, try the PCS WGS84 Web Mercator Auxiliary Sphere. If that one lines up, you know that's the right answer. I want you to try both and see which one's right. Now, there'll be a little quiz just like with the last one, but in the last one where I ask you a bunch of questions, I'm just going to ask you one. I'm going to ask you which one of these projections is the right one. Was it NAD 83 or was it WGS 84? And once you answer that, then if you get it right, you get your 12 points. So, this is sort of way it looked. Wrong counties added in, and you can't see it because I cut off the picture. But far over to the right of the screen would be the actual county boundaries, and so they're not lining up. And so that would be an indication that I need to go in and use the define projection tool, because I know that this projection is not defined. And how can I tell? Right click, layer properties, it'll show that it's not defined, and then you can look at the units and tell whether it's meters, feet, what have you, and get some idea what it could be. But I've already narrowed it down to 2 for you, and so you're just going to try to find which of those 2 is the right one, and then use that to answer the question. Alright, good luck.